Do you feel the vibes?
Okay, so in 1.2, we're going to talk a little bit more about functions. Let's start with what a function is, right? So we have the equation of something, and when you graph an equation of a function, right, why does the graph look the way it does, right? So basically, if you put in a set of values into the function, and if you just list the values of x, f of x, x, f of x, x, f of x, right? And then if you plot all of those and graph them, what that maps out is the graph of a function. Okay? Where are your notes?
I didn't get the in class.
Oh. Who else doesn't have them? Okay. So now at each point x, the value of the function is also the distance of the graph from the point x, right? On the x-axis. So for example, at x equals 1, if f of 1 is equal to 5, that means at x equals 1, the graph is 5 units above the x-axis. If at x equals -2, f of -2 is -3, that means at -2, the graph is 3 units below the x-axis. And it is really helpful as you go into upper level math to think of the y value as the distance from the x-axis away to the graph, right? X-axis away to the graph. Okay. Now, we can obviously use either the function or the graph to estimate y values, right? So take a look here. We have the function x squared minus 4x plus 4. We can estimate the graph. We can use the graph to estimate these function values and then use the function to find the actual values. So for example, just by looking at the graph, we know that f of 1 equals what? 1. And then algebraically, f of 1 is 1 squared minus 4 times 1 plus 4. Lo and behold, also 1. Now, when I look at f of 3.5, so this is 2, 3.5, right? And if I follow this up, it's right here. It's the middle. It's right here. Right, it's about 2.5. So now look, so this y value is between y equals 2 and y equals 3. If it's calibrated by ones like this, the most precise you can go is 0.5, because you really can't say if it's 2.1 or 2.7, right? So I want you can't say 2 or 3 either. So really what I want you to estimate this as using the graph is 2.5. Now, obviously, algebraically, you can get the more precise answer, right? So f of 3.5 will be 3.5 squared. What do you mean not complicated? Life is complicated. Huh? What? So you're going to use your calculator for this. Yeah. And you actually get 2.25, right? So you see, like, by the graph, it's a pretty good estimate. And then this is 2.25. Okay? Yeah. Obviously, integer values are, more, like, accurate. Okay. So let's talk about domain and range. This is just review, but we are going to use interval notation only. Okay, so domain here, we go from -4 to 4, but notice you have open circles here. That means When we go from -4 to 4, they are both open circles. And again, right, it's easy to sell interval notation because of how like efficient it is, right? And then the range is from -4 to 0, open at the 0, but closed at -4 because it actually hits y equals -4. There's not an open circle there. Okay, the domain for this function is -infinity to +infinity, and so is the range. Okay, domain here is everything except for x equals 2. So we have to open it at x equals 2. So it's -infinity to 2, union 2 to infinity. And there's only one way to write these. There is no other way. There is no artistic creativity here, okay? And then the range is from what to what? You mean 1 to infinity? Yes, 1 to infinity, y values. Okay, what about domain for this one? -8 to 6, all inclusive. You don't stop at the 0, right? Because where one leaves off, the other one just picks up. So, and it's closed on both ends. Now the range goes from 0 to 8. Right. Closed and then open. Fabulous. Okay, let's talk about intercepts. Okay, y-intercept right here. To find the y-intercept, you just find f of 0, right? The y-intercept is where x is 0, so you just find f of 0. Just plug in x equals 0. Easy as pie. All right. To find x-intercepts at these points, right? At those points, how much is the y value? 0. That's why the x-intercepts are also called the zeros of the function, because y is 0 there. The function is 0 there, right? So on the graph, it's the zeros. If you have the function to the graph that corresponds to the graph, the solutions of that function or the roots of that function correspond to the same points. To find the zeros of the function, you set the function equal to 0 and you solve for the independent variable. So x-intercept, solutions, zeros, roots all refer to the same points. Okay, let's do this. Again, the point of this is not just to find the answers, but to make you sophisticated math students, so form also matters. Y-intercept is really f of 0. So this is how you're going to write it, f of 0. And so what is f of 0 here? 0. That's it. That's all you're going to say. F of 0 equals 0. Now, for the zeros, you're actually going to set f of x equal to 0. Now, f of x is x cubed minus x. Factor out an x. This is all algebra 2. So x is 0, x is 1, x is -1. But when I write it, I'm going to write the zeros in coordinate form. Like this. Isn't that fun? Huh? So the y-intercept also happens to be a 0, which is fine. It can double. Yeah. Okay. This one, what's the y-intercept? F of 0 equals -3. Okay, then for the zeros, 2x squared minus 5x minus 3 equal to 0. Let's factor 2x and x. Is that right? Yes. X equals -1/2. x equals 3. So the zeros are negative half, 0. Ooh. 5x. Okay? So I was just about to say, don't put union in between these zeros. And then as I was thinking it, I mistakenly was putting it myself. Don't put union in between these, right? Because these are not intervals, these are points, right? So they are separated by commas. Yeah.
For the y-intercept, should we do f of 0 equals negative 3, or should we do 0?
No, f of 0. Because you're really looking, like you're saying the y value, right? It's y equals negative 3.
Okay.
The y at 0 is negative 3. Yeah. Okay. Symmetry. It's a beautiful thing. Let's talk about it. Yeah.
Just for the zeros, to find the zeros, if it's not either like quadratic or
If it's not factorable, use the quadratic formula.
Okay, because like in algebra 2, like we had all those different types of things to find the zeros, like the denominator zero, that.
Yeah.
Wait, is like the difference of factoring?
Huh?
Is like the difference of factoring, like repeating a square and those things?
You're talking. Slow down.
Is that like the different types of factoring?
Yes.
Like repeating a square and those things?
Yeah.
It's like the one box in the notes. That all the units in one box.
Sure.
I know. I remember studying the one box. It was like all the different types of factoring. That pretty much started being fair unit.
Mm-hmm.
And like, I don't know why.
I mean, it wasn't a box like this. It was a box like this.
No, it was like this size box.
I'll show you the box. It's like a box.
I have the box.
Okay.
I've seen the box.
Okay.
I know.
All right. Okay. All right. Listen, factoring is so algebra 2. I taught you factoring last year. Now you just do it. Okay. Let's talk about symmetry. So, a function can have symmetry with respect to the x-axis, the y-axis, the origin. If a function is symmetric with respect to the x-axis, this is how it looks, right? So basically, if you fold it vertically along the x-axis, the top and the bottom will match perfectly. What that means is, right, if let's say you have, y equals positive 3 and y equals negative 3, right? They will both match up to the same x value. Okay? Which means to check if a function is symmetric with respect to the x-axis, you want to substitute negative y for y and simplify. And if the result is the same, then it's symmetric. Okay. So, with respect to the y-axis, right, this is how it looks, right? So, if you have, good luck, if you have, different x values, so for example, x equals negative 4, x equals positive 4, they will correspond to the same y value. So, opposite x values will produce the same point, okay? So to test if something is symmetric with respect to the y-axis, substitute negative x. And if the result is the same, it's symmetric. Okay, for this one, look at this one. Look at corresponding points here. So like 3 comma 4 is the same as negative 3 comma negative 4. So that means what we're going to do is to check if something is symmetric with respect to the origin, we're going to substitute negative y and negative x, and then we're going to see if it's the same. If none of these work, then there is no symmetry. Okay, so let's take a look here. You can visually check for symmetry. So like this first one, is there any symmetry? Around what? X-axis. What about this one? Y-axis. What about C? Origin. What about D? y-axis. Okay, now if you're given a function, you gotta show work, right? So what you want to do is you want to divide your workspace into 3. So you're gonna look for symmetry around the x-axis, the y-axis, and the origin. Okay? For the y-axis, for the x-axis, you want to switch y into negative y. So basically, you take your function and then you substitute y for negative y, or negative y for y. So we have negative y equals x cubed. Right? Simplify. You get y equals negative x cubed. You didn't get your function back, right? That's not your original function. So that's not symmetric. Here, make x negative x. So y equals negative x cubed. And when you do the operation y equals negative x cubed, that's also not the same function. Here, you want to make xy into negative x negative y. Oh my gosh. Right? So let's see. Negative y equals negative x cubed. Negative y equals negative x cubed. Negatives cancel. Y equals x cubed. Okay, that does return the same function. So this is symmetric around the origin. Yeah. Well, yeah. You just put in negative y. Then it'll become like negative negative y. You know what I mean? Yeah. Yeah, like don't just change the sign. Because if there's an operation, like actually insert negative y.
Can something be symmetrical around multiple like axes or like around like?
Yeah, like if you have the equation of a circle centered at the origin, it'll be symmetric around all 3 of them, which is okay.
But that's like it.
Yeah. And then you might have like, yeah, you might have like an ellipse. Yeah. Right, but it's okay. It's okay. It's okay. It'll still be, right? Because this doesn't say determine the symmetry of the function. It just says determine the symmetry of this. So it'll be okay. Yeah, yeah.
And also, like, looking at this one, could we kind of have, like, hypothesized it would be symmetric around the origin because it's one of those, like, it's a cube?
Yeah. But you gotta show work.
Right.
Yeah.
Okay, but, like,
Right.
if we get that it's
Right.
Okay, that makes
Yep.
sense. Okay.
Precisely. Okay, moving on. More tests, even and odd functions. Okay, an even function is basically symmetric with respect to the y-axis. An odd function is one that is symmetric with respect to the origin. The test for these, okay, this is like a standard test. The test for these is you want to substitute negative x. So you want to find f of negative x, right? This is like one of those things where like if you're walking down the street and like you tap someone on the shoulder and say, what's the test for even and odd? They'll be like, oh, find f of negative x, right? Like that's the standard, right? So if f of, oh my God, how funny would it be if somebody is like, find f of negative x, right? Like, oh my gosh.
I'm gonna do that tomorrow.
Right? Yeah, yeah. Right? Yeah.
$10.
Yeah, right? Oh my gosh, how cool. Oh my gosh, I wish somebody would ask me and like offer me $10. Right? Yeah. Go to Hollywood Boulevard and just be like, how do you find even and odd functions? Yes. How do you test for even and odd? So if f of negative x equals f of x, then the function is even. If f of negative x equals negative f of x, then the function is odd. Okay? Okay. So, before we do this, let's go up here. Oh, I know. Let's go up here. Remember how we said even functions are symmetrical on the y-axis? Look at this one. B is symmetrical on the y-axis. So let's take a look at this, okay? What's f of 2? What's f of 2? 1. What's f of negative 2? Oh my. 1. 1. You see how they're the same? That means this is an even function, right? Because f of 2 and f of negative 2 are the same. It's an even function. All right, now take a look at this one. Take a look at this one. See, what's f of, 2? Negative 4. Now what's f of negative 2? 4. You see how they're opposite? This is an odd function, right? Because f of 2 is negative f of negative 2. Okay, I'm not going to take questions right now. Let's do these. I'm going to do these and a couple more, and then I'll take questions. Okay, look at this one. Okay, so we find, okay, look, again, it's all about showing work, right? If you have the right answer, honestly, you have 1 1/3 chance to get the right answer. It's either even, odd, or neither. And if you don't have correct supporting work, you're not going to get credit. So f of negative x is negative x squared minus 4 times negative x plus 4. F of negative x is x squared plus 4x plus 4. So now you ask yourself, did I get the same function back? No. Did I get the negative of the function back? Also no. To get the negative of the function back, every single term has to switch signs, which this didn't. So this is neither. Yeah.
What happened to the negative in front of the x squared?
Negative x quantity squared becomes positive x squared. Okay, so this one, f of x. Okay, so now we're going to do f of negative x. Negative x squared minus 4. So f of negative x is x squared minus 4. So what did I get? Okay, but look, f of negative x is equal to f of x. You have to write this down. Therefore, this is even. That's the therefore symbol. It's a triangle. Now look, moving along, as you move into higher level math, right? No one's going to ask you, is this even or is this odd? They're going to say, show that this is an even function. And then you have the answer. Now it's about the work, right? So you have to show work, right? And this is the work. This is the justification. Okay, so f of x is that f of negative x is negative x squared, negative x to the 4 plus 1. F of negative x is x squared over x to the 4 plus 1. Okay, f of negative x is equal to f of x. Therefore, this is even. Okay, look at this one. F of negative x is 1 over negative x. F of negative x is negative 1 over x. Not the same function. This is the what? This is the negative of the function, right? So we say f of negative x is negative f of x. So this is odd. Okay, this one, we don't need to do it, right? You're all good. Instead of this one, I'm going to give you another one.
Wait, why is that one so
I mean, it's redundant. It's even. We know. Okay. So instead of that e, I'm going to give you another e. F of x is cosine of x. Oh. F of negative x is cosine negative x. This is what? Cosine of x. So f of negative x is equal to f of x. So this is an even function. Right? Did you see that? Right? Remember f of negative theta is the same as f of theta, right? Do you remember cosine of negative theta is the same as cosine of theta? Well, it's because it's an even function. Okay, now, what if f of x is equal to sine of x? F of negative x is sine of negative x. F of negative x is negative sine of x. So it's odd. What's tangent? No, even. Odd, because tangent of negative x is negative tangent of x. Now look. Let's graph cosine. Is it or is it not symmetric with respect to the y-axis? That's an even function. Let's graph sine of x. Symmetric with respect to the origin, right? Hello? Huh? Tangent is symmetric with respect to the origin, right? And f of negative x is tangent of negative x, which is negative tangent of x. This is a mic drop if there ever was a mic drop. I mean, honestly, right? Look at how harmonious math is, right? And if you all think math is like different compartments, no. It all fits together. This is like math nirvana we're in right now, okay? Yes.
So if we're basically symmetric around the x and y axis, or no, around the
not x-axis, y-axis.
Symmetric around the x and the y-axis and the origin are both odd.
Look.
Oh, so there's no respect or there's no symmetric. So if it's around the x-axis, it's nothing.
It's nothing. It's not a function. If it's symmetric around the x-axis, it's not really a function, is it?
So that's not a function?
No, this is not a function.
No, because it would have cost them work.
Wait. Oh, that's definitely less than one.
It's not a function. It's a relation. Yeah.
So I can't write f. It's not allowed.
No.
Okay.
I don't really understand what you mean when you say even and odd, because we're not talking about the degrees. So
No.
what are we talking about?
Well, it is kind of degrees. Because
A is either, but it has even degrees. Not A on
A?
example 4, on example 5. Like it's an even degree.
okay, but its end behavior follows even degree behavior, right? It's like a parabola.
Right.
If you graph this, it's like a parabola.
Yeah.
Okay, but it's mixed in with this. This is the parent function is even degree. So even functions and odd functions, yes, they are not degrees.
So what do we mean when we say even and odd?
Literally this.
No, I know, but like where is the even and odd come from?
It doesn't matter.
Not from.
It's a way to name the graph. It's another way to say something exists.
But like,
It's a definition.
Okay, because the parent function, when you have even degree and odd degree, or
but when you add like the negative 4x plus 4, it becomes even.
right, but don't think of them as degrees because sine and cosine and tangent also follow even and odd functions.
Right,
So they're different things. Because you know what? There's just not enough words for all of these things, right? So
I just don't get what even means.
even means symmetric around the y-axis. That's all.
Forget about any definition you ever
Right?
had even before. Now this
Even function, and even, this is it. This is the definition. An even function is a function that is symmetric with respect to the y-axis.
No, I get that.
That's
I just
it.
don't know where even came from. But
That's it. I mean, it could have been called a Zoe function, but they just didn't know back then. Yeah. Yeah.
It's the circle, or the middle, or was
Yeah.
would that be all?
Yep. All three. It wouldn't be a function though. For shame. Yeah. Yeah. All right. Why don't we do homework? Because you guys have a lot of homework to do. Huh? I don't have any graph paper.
It's actually a lot of homework. Well, this
Well, because if you didn't do last night.
does 1.1 is 1.1 graphing. Wait, leave it for a surprise.
Yeah, but some of them is just like look and see if it's even around.
Oh, okay, that's fine. I got scared of the number of problems.
So, 1.2 is graphing, right?
I don't even know. I don't think so.
Because I just did it on my paper.
Oh shoot, this is still going.
Press start.